In this lesson, you're going to learn about projected curves. Projected curves can be accessed from the Surfaces toolbar on the drop-down and Projected Curve. There are two flavors of projected curve. One is a sketch projected onto a face, and the other is a sketch projected onto another sketch. Let's take a look at both of these functions. When we say projected, we mean that a sketch, such as this S at the bottom, is pushed perpendicular to its sketch plane until it runs into something. In this case, it'll run into this surface. This could also be a solid. And this is the Sketch on Face option. So I select the sketch that I want to project. And remember, the projection direction is always normal or perpendicular to the sketch plane. And if I select the face that I want to project it onto, SOLIDWORKS gives me a preview of what that curve would look like in 3D. The orange preview on the pink. Now that's a projected curve. There is another type of projected curve, and this is the sketch-on-sketch projection. Some people have difficulty visualizing this, so I'll show you in a couple of different ways how it works. First, we'll invoke the Project Curve tool and change to the Sketch-on-Sketch option, and then select the two sketches that we want to project. Normally, these sketches are on planes that are perpendicular to one another. So when you look at the curve from one point of view, it will look like one of the sketches. And when you look at it from another point of view, it will look like the other sketch. So in this case, it's like a reverse 2D drawing view, where you're creating something 3D from two separate flat views. Another way to think about this, if we turn on both sketches that were used to create the second projected curve, is that if you extrude one sketch through space and then extrude a second sketch through space, what will the intersection look like between those two curves? And if I hide this second curve using the display pane, I can use the intersection curve option to select these two intersecting faces and click OK. The intersection curve gives the exact same result that you would get from the projected curve. Intersection curve gives a 3D sketch, and the projected curve gives a curve feature. As mentioned before, curve features have some limitations and drawbacks in SOLIDWORKS, and in general, you may be better off with a 3D sketch anyway. The other types of curves that are available in SOLIDWORKS are the split line, which is actually not a curve, it creates edges. The composite curve will take other curve entities and actually sketch entities and edges, and it will make a single joined together curve out of them. Through XYZ points will allow you to key in values for XYZ, and SOLIDWORKS will make a curve from those points. The curve will work much like a spline, except that you will not have control of tangency at any of the points. Curve through reference points allows you to select actual sketch points or model vertices through which to create a 3D curve. The helix and spiral should be self-explanatory, but we will go over it later on in this chapter. There's another curve that's available. SOLIDWORKS does sometimes confuse the words curve and sketch, but under Tools, Sketch Tools, there is a function called intersection curve, which again is the 3D spline, face curves, which are also 3D splines, and equation-driven curve under the Sketch Entities menu, which also creates a 3D spline.